Functional dependency is a key concept in database design that describes a relationship between attributes in the same table of a relational database. Specifically, a functional dependency exists when one attribute, or a set of attributes, uniquely determines another attribute or set of attributes in a table. To continue clarify functional dependency, let A and B be attributes of a table. We say that B is functionally dependent on A, denoted as a determine B, if for every unique value of A, there is exactly one corresponding value of B. For example, if A is a student id, and B is the student's name, then each student id uniquely determines a student's name. Therefore, student id determines student name. We say student name is a functionally dependence on student id. Functional dependency importance in database design. First, one importance in normalization process. Functional dependencies are fundamental to the process of normalization, which involves organizing a database to reduce redundancy and improve data integrity. By understanding the functional dependencies in a database, designers can structure the tables to ensure that each piece of data is stored in only one place, reducing the chance of inconsistencies. Second importance of functional dependency is in data integrity. Ensuring that functional dependencies are properly defined and enforced helps maintain data integrity. If a database adheres to the principles of functional dependency, it ensures that data is consistent, accurate, and reliable across the database. Third importance of functional dependency is in avoiding anomalies. Poorly designed databases can suffer from various anomalies, such as update, insert, and delete anomalies. Functional dependencies help prevent these issues by ensuring that each piece of information is stored in a controlled and logical manner. Fourth importance of functional dependency is in efficient querying. Understanding functional dependencies allows for the creation of more efficient queries. When a database is properly normalized based on functional dependencies, it reduces the need for complex joins and data retrieval operations, improving overall performance. In summary, functional dependency is a critical concept in database design that helps ensure a well-structured, efficient, and reliable database. Functional dependencies, FDs, in database design can be categorized into several types, each serving a different purpose in the normalization process. Here's an overview of the different types of functional dependencies. First type, trivial functional dependency. A functional dependency determine B. A determine B is trivial if the set of attributes on the right side is a subset of the set of attributes on the left side. Trivial FD example, if it equals a group contain employee id and employee name, then employee id, employee name, determine employee id. And this is a trivial dependency because employee id is part of the left-hand side. Second type of functional dependency is non-trivial functional dependency. A functional dependency A B is non-trivial if the set of attributes on the right side is not a subset of the set of attributes on the left side. Example, if it equals employee id and B equals employee name, then employee id determine employee name. Employee id determine employee name is a non-trivial dependency because employee name is not a subset of employee id. Third type of functional dependency is full functional dependency. A functional dependency A B is a full dependency. If B is fully dependent on A, and removing any attribute from A means B is no longer dependent on A. Example, in a table with a composite primary key, student, course id, if student id, and course id determine grade, and neither student id nor course id alone determines grade, then grade is fully functionally dependent on student id and course id, a composite primary key. Fourth type of functional dependency is partial functional dependency. A functional dependency A determine B is partial if B is dependent on a part of a composite primary key, rather than the entire key. Example, in a table with a composite primary key, student id, coursid, if student alone determines student name, studented student name. But coursid is not needed to determine student name. This is a partial dependency. Fourth type of functional dependency is transitive dependency. A transitive dependency exists when a determined B and B determined C imply a determined C transitively. It occurs in situations where one attribute depends on another through a third attribute. Example: if student determines department and department determines department_head, then there is a transitive dependency studented department_head. Studented determine department_head through department. Fifth type of functional dependency is multivalued dependency. A multivalued dependency occurs when one attribute in a table uniquely determines another attribute, but the second attribute can have multiple values for a single value of the first attribute. Example: if employee determines dependent name, and an employee can have multiple dependents, then employee multivaluedly determines dependent name. Sixth type of functional dependency is joined dependency. A joined dependency exists if a relation can be divided into two or more tables, which when joined together, recreate the original relation. Example: consider a relation R with attributes A, B, C. It can be split into two relations, A, B, and B, C, that, when joined on B, recreate the original relation R, then R has a joined dependency. Seventh type of functional dependency is embedded dependency. An embedded dependency is a dependency that holds only within a specific subset of the database rather than the entire database. Example: if a functional dependency holds true only within a certain department of a company, it is considered an embedded dependency. Significance in database design: understanding and applying, correctly identifying, and applying these dependencies during the normalization process is crucial for minimizing redundancy and ensuring the integrity of the database. Normalization: many of these dependencies play a role in the normalization process, helping to break down tables into smaller, more manageable pieces without losing important relationships.